Okay, so we're going to finish up on implicits today. So I think we've seen a lot of it already. Basically, the big idea with implicit is that if your equation feels out of place with your y variable, you know you have to involve dy dx in your process. But still treat x the same as you would in the past. But if you see any y variable, take whatever derivative rule it needs, which right now is just power rule, and then attach a dy dx. But sometimes the more involved problems may include product rule, especially if your x and y are next to each other, they're being multiplied, you got to go through product rule there. So we'll practice with that today, and then we'll go through your packet, and your packet has all the test review problems, so we'll get to do it the rest of this week. If you look on the board there, I have help sessions leading up to Friday. And I'm also going to send you a text reminder probably this morning, so kind of like during advisement, just so you can have it listed out for you. So today, this afternoon, I'll have a help session at 3:30. Wednesday morning and Wednesday afternoon, 7:30 and 3:30. And then Friday morning, that's the day of your test, 7:15 o'clock, 7:15 a.m. And I will send out Teams link for each of those if you want to join virtually, and they'll all be recorded. So I'm just going to place them directly on the date where I held that session. So if you just go to now, make sure that you're on unit 3. So if you go to unit 3 under today's dates, I will put that video link there. And yeah, usually by Wednesday, I'm not able to send out reminds. So if I'm not able to send out reminds for the Teams link, then just go to Wednesday 9:20, and then I should have a Teams link there right around the time that I start the help session if you want to join virtually. Okay, so let's go. We're going to do some more implicit differentiation work and just make sure you guys can get more comfortable with it. And so if you guys can turn to page 11, and you'll look at number 5. And then page 13 is the key. So all these worksheets, I have the key attached right behind it. So if you look at number 5 here, let's list out what we think is going to happen. So number 5, x cubed minus xy plus y squared equals 7. What do you see there? If we want to find a derivative, what's involved? Implicit because? Yeah. You see all these trouble spots with y's, right? You have multiple y variables. You have y raised to a power. You have y's mixed in with x's, right? Any of those 3 things, if it happens, we know there's implicit, right? So it doesn't quite look like the equation we're used to, where it's y equals and then all your x terms grouped together nicely. Okay, so we know we have to involve implicit. What else? Product rule, y. The x and y are together, right? They're being multiplied. We can't just say, oh, x is 1 and y is dy dx and then be done with it. We got to go through that product rule. Okay, so now there is a potential trouble spot within product rule for this problem. Can you identify what that trouble spot could be for third? No, well, x cubed third, that's fine. That's power rule. We have no issues there.
XY.
Yeah, there's something about that xy. Yeah, what is it about that negative that could cause some issues? Good. We got to distribute. So if I have minus f times g, and if I want to go through product rule, you want to put a minus sign in front and then do f prime g plus f g prime, because if you don't protect that with a set of parentheses, your product rule will remain a plus in between, you got to make sure you distribute through. Okay. So let me rewrite the problem here. And then see if you guys can go through this process. Actually, I'll walk us through this here. All right, x cubed minus xy plus y squared equals 7. We're recognizing the need for product rule. We're recognizing the need that that there's a plus that's going to show within product rule, and that minus has to distribute through. So there's that additional step. Okay, so let's walk through each term here. So x cubed becomes 3x squared. Nothing special with x's, right? We know that it's just going to be power rule. Okay, so now I'm going to spell out product rule here for the next term. Okay, f prime. What does x become? G is y, no changes. Back to f, x, and then what's g prime? Good, so y disappears, but we are asking for y's derivative. Y becomes 1, but then we attach dy dx. Oops, sorry, forgot the next term. Okay, plus y squared, what does y squared become? Good, right, dy dx, right? We have to make sure with the y's, we have to hash that special derivative variable equals 0. Good. 7 is also getting impacted. 7 is a constant. It goes to 0. If you look, there are two times when y show up. So you're expecting 2 dy dx's to pop up, and you do see that, right? So however many y's you see at the beginning of your equation, or your derivative, that's how many times your dy dx shows up. Okay, question.
Why do you incorporate like the y with a dy dx, like the plus 2y dy dx? Why don't you like give it a 2y? Why do you?
So the rule is that anytime you come across y, you find the derivative of y, and then immediately after that you attach the dy dx. So that's what we do for all of the y variables. I mean, technically we've been doing that this whole time. If I have y is equal to 3x squared plus 4x, right? What's the derivative? 6x plus 4. Now, we never did anything with this y. We just call y what? Y prime. But really, we are doing the derivative. The derivative of y is 1, and then we're attaching a dy dx to that. So we've been doing this whole time. It's just that because this has been the same every time, the derivative has always looked the same every time. All right, so any questions here? This is really the most important step because this is the only calculus step. The rest of it is just trying to move things around and try to solve for dy dx. Okay, so now let's just do some cleanup. I'm going to distribute the negative through, and then I want to collect the dy dx terms on the left side, move the non-dy dx terms on the right. Okay. Okay, what's next? Factor, yeah, factor dy dx out. Final step. Divide out the parentheses, yeah. Question, yeah.
So why doesn't the like the G, why get a dy dx?
Oh, why is it G prime? Oh,
Oh,
okay, good.
that
Why,
one.
right, why does the G not get the dy dx? Okay, why is it? Why do we not do dy dx here for the y?
Because we have to get power.
Okay, because G is not asking for the what?
For the-
Derivative, yeah. So we only do derivative. We only do dy dx if there's something with the derivative that is asking for. Yeah. So within product rule, there are some parts where the derivative is not required. So that's why, we just copy down exactly what we see from the F and G portion of our product rule. Okay, questions? Okay, so I want to show you an old free response question that did show up on the AP exams. It's a long time ago, but I think it's a good one for us to do practice on. So on page 15. Okay, we're just focused mainly on A and B, but then I'll talk about part C and then we will dig a little deeper there. But okay, so it says consider the curve given by xy squared minus x cubed, sorry, xy squared minus x cubed y equals 6. Show that dy dx equals. So don't worry about this. Then, well, it's asking to find dy dx. Okay. So if you look at how this equation is set up, can you identify what is involved if I want to find the derivative? Let's list those things out. Product rule. Okay. How many times? Twice. You see that xy squared, there's a product of two different variables there. Then the second time, x cubed y, another product rule here. Okay. And obviously there's y's mixed into the equation, so we know we have to involve what?
dy.
Yeah, so implicit, right? And then what's the trouble spot for one of the product rules here? Yeah, that negative. So you got to make sure that put a parentheses around the second set. We don't have to worry about having the parentheses in front of the first one because there's no negative in front. We're not going to run into an issue with the signs being incorrect because it's just a positive. But that minus is going to cause an issue for our f prime g or f, the product rule if we don't protect it with a set of parentheses. Now it says show that this is equal to this. So we're not going to start here. Okay, this is where we're going to end up. So the nice thing about this problem is that they're telling you what the answer is. You just have to fill in the gaps to get from the starting to ending. That's where for this problem, at least, that's where the points are stored in the process, not in the answer. They're telling you what the answer is. All right, so okay, let's go ahead and set this up. I will go ahead and set up the two product rules and then see if you guys can move through. The key is on the back, but see how far you can get on your own first. Okay, let's see what we gathered here. F prime g plus f g prime, so x becomes 1, g is y squared, f back to x. G prime, y squared becomes 2y. Okay, we are asking for y's derivative, so that's where that dy dx shows up. Also, if you look at our original equation, you look at your original equation, there's only 2 times when you see y variables show up. So ultimately, in the end, we're expecting 2 dy dx's to pop up. Okay, so we're done with the first product rule. The second product rule, f prime g plus f g prime. F prime is 3x squared. We keep the y plus f g prime, so x cubed, and then y's derivative is 1, and then we need to attach dy dx, so dy dx shows up. Don't forget about that 6. The 6 is not going to remain a 6. The 6 will get pushed to a 0. Yeah.
How come on like all the other product rules, you would divide it by g squared or whatever?
Right. Yeah. So So when do we do divided by g squared? That's quotient rule, right? So quotient rule is if it was, like x cubed minus y over x squared plus y. Yeah, then we got to do f prime g minus f g prime all over g squared. But product rule is just the numerator. It's a plus in between that. Okay. How do we feel so far? Okay, right. So now that's the hardest part, right? Trying to get that through. In fact, pretty much all the points is you've earned it because you did all the calculus portion. The rest of it is just trying to get that dy dx by itself. And the nice thing is, for this problem, it's telling you exactly what the answer is. So you just have to make your answer look like that, right? So what I would do first is distribute the negative through. There's going to be 4 terms that are kind of clumped together, and you just have to kind of move those terms around. Get your dy dx terms, collect them on the left side, move the non-dy dx terms on the right, and then you can factor dy dx out, divide the expression over to the other side. Okay. Now, it's possible that if you move terms in different ways, that you may get a negative version of these. So we talked about how if your answer is similar but not quite exact the same as what they're presenting, you can always multiply the numerator denominator by what to create a different version of your fraction. -1, yeah. So multiply the top by -1, distribute -1 to the denominator, and that should give you a different version. If for some reason your version is almost identical, but the signs are off. So y squared plus 2xy dy dx. I distributed the negative through, and now I have 4 terms that are nicely identifiable, and I can just collect my dy dx terms on the left, move the non-dy dx terms to the right side. I'm going to add or subtract whatever it takes to get me to the other side of the equation. Factor the dy dx out, and then divide everything over to the right side. So it looks messy, but well, I mean, the nice thing is that it matches exactly with what they want they're presenting to you. So that's the derivative. And again, why can we not go any further? I mean, we see some x's and y's that are paired up. And then there's a minus and plus sign. As soon as your terms are added or subtracted to another term, unless you can somehow find a GCF from both your terms in the numerator, and then it matches the GCF in the denominator, then you can remove those, but we can't go any further. And this does the same job as other derivative equations. It gets you a slope of the starting equation, right? So whatever this curve looks like, I can plug in this case, I need a full order pair. It'll get, plug in that full order pair, I'll get a number, and that number will correspond to how steep this point is on the original curve.
So is there one of these FRQs on our test?
Maybe not FRQ, but I mean, it'll be a free response. Well, basically, like, yeah, it says, we'll be like, hey, find the derivative of that equation.
And on the top it says like show that dy dx equals like 3x squared y minus y squared divided by 2xy minus x to the third. Will it like always be like proving that? Are you always gonna get to that point? Is there like a way you can like prove it? Like, what am I trying to say? It's certain that it equals that, right? Like,
Oh, right. Yeah. So it's
you
just,
gotta- you
it's
gotta
just,
prove it.
right. But, you know, I'm not saying that, you know, I'm going to give you the answer and then it may not be presented this way on the test.
Okay.
This is just a particular free response question that showed up on the AP exam, but not every FRQ is going to have the same format. You know what I mean? Like,
Yeah.
it's just going to be, you know, in terms of X, you're definitely going to see implicit on the AP exam. It may come up to you, come out as a free response type problem, but chances are the implicit is going to show up on the multiple choice. Yeah, this is not a guaranteed topic on the free response. Usually, or if it shows up, it's not the main content. It could be like a part C or part D of another problem. Yeah. But just want to kind of give you a taste as to what an FRQ could look like. There's usually like usually like 3 or 4 parts, and each part is worth a certain number of points out of 9. It's always out of 9 points each FRQ. Okay, so now we're going to use what we gather from part A to help with part B. Part B says, find all the points on the curve whose x coordinate is 1 and write an equation for the tangent line for each of these points. So let's think about what information do we need to gather if we want to write an equation for a tangent line. You guys experienced this on the quiz, maybe not with implicit, but it's the same process. What information do we need if we want to create our tangent line equation? Well, yeah, that'll get you your order pair, and then you also need to find the what?
Slope.
The slope, right?
Which you already have.
Well, you have a slope formula. But what information do you need if I want to get the actual slope at a point?
The coordinates.
That's right, the coordinates. And the good thing is they give you one of the coordinates, but they don't give you the full coordinate. So how can we find the full coordinate?
Well, you next.
Into the, well, plug the 1 and get the original, yeah. So let's try that. We're going to plug the 1 into the original first. We're going to get some information. Now, it says find all the points with x coordinate is 1. That's kind of like a hint saying that there could be more than 1 because we're not dealing with a nice function here. So you may have points that are above each other because could be a graph that, you know, doesn't pass vertical line test. So if there are 2 points, then that means we got to find the slope twice because each point may produce a different slope. Okay, so we'll insert 1 back into the original equation and see if we can get some information there. Okay, so I'm taking my original equation, replacing all the x's with 1s. So I get 1y squared minus y equals 6. And this is going to be a factoring problem, right? We know that if we see any type of quadratic and linear and a constant, we don't want to do GCF with the y's. We want to bring everything over to the same side, factor, or get that 0 to show up. Okay, so this should be factorable, right? Y squared minus y minus 6. What multiplies to be -6 and adds it to be -1. -3 and 2, yep. So we go ahead and go through factoring here. So I get 3 and -2. What does that tell us? Good, okay. And but how many order pairs do we have then?
Just
Two. What are our two order pairs?
1, 3, 1, negative.
Yeah, 1, 3, 1, -2. They both have the same x value of 1, so 1, 3, 1, -2. So how can I find the slopes at those points?
So in each one separately.
Into what?
Then dy dx.
Get to the derivative, that's right. Yeah, get separately. So we're gonna find, we have order pair, one order pair into the derivative, that'll get us our slope. Then we do point slope form, right? Then the other, we got to do this process twice, right? Then the second order pair into the derivative, we get that slope and we create that equation, that derivative equation. Sorry, that tangent line equation as well. Okay, so we have two order pairs, 1, 3, and 1, -2. Back into the derivative, it goes, right? So let's do 1, 3 first. We'll get a slope that corresponds for this point. Again, I know this looks messier than other derivatives, but it does the same job, right? But it just requires a bit more information. Instead of just the x, it needs both the x and the y. Okay, so I took replace all the x's with 1s, replace all the y's with 3s, and I got 9 minus 9 over in this case 5. So 0 over 5 is still going to be a 0, right? We know that's a real number. So the slope is 0. So let's do our point slope form. You can leave your answer unsimplified, but this is easy enough where you can just get that y by itself. In this case, y equals 3. So that tells us that at this point, there's going to be a horizontal line right at the top of the graph. Okay, so we know there's another tangent line at 1, -2. So we'll take that order pair, put into the derivative, get our slope, and then again, point slope form.
So you can't simplify this one.
You could, but we said that point slope form, College Board will accept it. So the previous one, if you wanted to say y minus 3 equals 0 times x minus 1, that's fine as well. It's just I felt it was easy enough to clean up, but you didn't have to. You could leave it in that parentheses form, and you'll still get full credit. Great, thanks. Okay, thanks, Reese. Have I talked about vertical tangent and horizontal tangents? Yeah.
I don't think so.
Okay. Just a quick thing. We'll maybe do a full.
Isn't there a part C to this? Like,
There's a part C, but I think I'm gonna go ahead and I'll talk about it briefly, but this is more challenging, so I feel like we can come back to it if we need to. So the idea is it says find where the line is tangent line is vertical. So let's say the graph looked like this, right? Let's say it looked like a circle here. If I want to find a horizontal tangent, let's say I want to find these 2 points. These are places where the slope is what? 0. So if I want to find a slope 0, what I'm going to do is I'm going to set the numerator of the derivative equal to 0. Okay, that's the process of going through it. I just want to give you a little bit of a preview. So we're going to do a little bit later. And if I want to find a place where the tangent line is vertical, tangent line is vertical. What does that mean? That means slope is what? Yeah, slope is undefined. So if your slope is undefined, it looks like this, where places where the slope is either looks like a vertical tangent or it's a sharp turn. So if I want to look for places where slope is undefined, guess what I'm going to set equal to 0 to find the denominator. Yeah. So if your denominator is set equal to 0, that's going to help you find the locations where the slope is undefined. If you set the numerator of the derivative equal to 0, that's going to help you find the places where slope is 0, where the graph is actually kind of leveling off. And you can kind of imagine, standing on a place where you don't experience any steepness. All right. So I do want to come back to this concept, but just want to tell you horizontal tangent comes from the numerator, vertical tangents comes from the denominator, or we look for it in the denominator of the derivative. Right, but I want to do a product quotient and chain rule exploration on page 19. 19 and 20. So here it says, use the graphs of f and g, let p of x equals f times g, and let q of x equals f divided by g. It says, part A says find p prime of 1. Okay. Now, can you verbalize what is this asking for? Yeah, find the derivative of p at 1. So before I can find well, this will get me to the what though. This will find us the what of this graph. Slope, right? So, but before we get to the slope, we first have to get to the what? Derivative. Yeah, we gotta find p prime of x. So let's not worry about the 1. Let's just worry about, how can I find p prime of x? Now, look at how p of x is set up. What do you think we have to do if we want to get to p prime of x, looking at this f times g? What rule do you think we have to go through? Product rule. Yeah, we got to go through product rule. So let's build a derivative using product rule. Now, what's different here is this is in function notation. So the best we can do right now is to put everything in function notation. But I mean, basically, we just spell out the rule, right? P prime. We know that f and g are the variables that we normally associate with product rule anyway. So f prime times g plus f g prime. So now that we have the derivative in front of us, how do you think we can transition to this part here? Plug in 1 for all the x's, yeah. Now, rather than inserting into a derivative and function to get the order pair or to get the values, we're going to rely on the graph that we see here. Now, f of 1 and g of 1 should be easy, right? You're just looking for the location. You're looking for the y values at these points. But what do you think f prime of 1, g prime of 1 means if we're looking at the graph? Good, slope. The nice thing is these are all nice lines, so we should be able to find the slope at any of these points. But let me just highlight a few things about slope. Now, normally slope is just rise over run, right? If it's a diagonal line, it's easy. You just find 2 points and do rise over run, and that's your slope. What's the slope of this segment here? 0, yeah. So if you experience a flat surface, that's slope 0, okay? What about these places where you see a corner or you see a slight corner here? What is that? What's the slope there? Good, undefined. So anytime there's a sharp turn, we cannot do a tangent line to that point. So anytime there's a sharp turn, the slope is undefined there. Okay, good. So let's go through each of these here. F prime of 1. F prime of 1 is asking for, look at the F graph. I'm going to highlight 1 here. Now, I know this is a straight line here, so if I just find 2 points and do rise over run, I can find the slope of this line. It's going to be consistent all the way through. What's the slope of this line? 1, right? I pick a point. I just go up 1 over 1. That's a slope of 1. So that's exactly what I'm going to put in place of F prime of 1, just the 1. G of 1. G of 1 is asking for the order pair. So I'm going to highlight that point, G of 1. What's G of 1 equal to? Yeah, 1, 2, 3, 4. Yeah. Okay, back to F of 1. Now we're back to the same point, but we're asking for the order pair now. What's the Y value?
6.
6. Okay, next up, G prime of 1. I'm back to this point, but now I'm asking for the slope because you see that prime there. It's good. So you're going down 1 over 2. It's the steepness of -1/2. Do some cleanup here. 1 times 4 is 4. 6 and -1/2 is -3. And we get answer is 1.
Is what?
Oh, sorry. Answer is 1. Oh, sorry.
So the slope's undefined where it like changes to it.
Not only change direction, but where you can imagine if it feels sharp at that point, then that's a slope undefined. So if we look at this graph though, you see how there's like a smooth portion there. What do you think the slope here is? 0. Yeah. So if it doesn't feel sharp to you, if you can touch it and it's like a top a portion or bottom top of a hill or bottom of a valley, then that's the slope 0. Yes.
Why'd you do 4 months too?
Oh, I did some cleanup here. 1 times 4 is 4,
Oh.
and 6 times -1/2 is -3. So 4 minus 3 equals 1. Okay, let's see if we can just get started with part B here. Part B says find Q prime of 4, but before we can find Q prime of 4, we first have to find what?
Q from X.
Q prime of X. Now look at how Q of X is defined. F of X divided by G of X. Guess what rule we have to go through there? Quotient rule. Yeah. So the nice thing is they're defining it in how we normally define it. Top is the F, bottom is the G. Okay, it's going to feel very much the same process as A here. You're just going to plug in the order pair or the slope. We'll plug in 4 first, replace every X with 4. And then you're going to either get the order pair or get the slope. Okay, so your homework is just this page, page 19. The key is on the back, so you guys can, sorry, not back, but page 21. So you guys can check your key on the next page, but I will send out a reminder. Page 19, all is your homework. Help session this afternoon, and we can just continue to go through this tomorrow. All right, go get your phones. Yeah, thanks, guys. Oh yeah, it's on. Not tomorrow. If you look on the board there.
Okay.
Just today, Wednesday morning, Wednesday afternoon, and Friday morning. And I'll send out that as a reminder this afternoon or during advising today.
We'll be sorry, James Cook. You did really good.
He did, yeah. I benched him.
You
key
benched
players.
him?
No, I benched another player that.
Oh, okay.
That did well, and so,
Which player?
I think Miami.
Oh, yeah.
I'm okay to take the 10th 7th period.